My name's Aaron. I've got Brett beside me. He's running the chat and details beside me, inviting everyone along and letting you know whenever there's any questions. So obviously the focus today is around achieving a high performance home for your family and to a budget. I see on the notes here you obviously have already been through the mid-build at the Deco, and you're coming next week to our one in Hawesville, which is great. And yeah, we'll hopefully go through this presentation. We can provide some more information, and then if you've got any questions, just feel free to directly ask those. So thanks for joining us. I hope you find this session interactive and informative. If you want to type any questions while I'm talking, please feel free to do that. The focus is going to be about high performance homes, including the principles needed to achieve a high performance home and how we actually achieve that to a budget. If you do have any questions, as I said, just put them in the chat box. A wee bit about us and our background. We've been going since 1998, and when we started, it was predominantly architectural and hillside homes, but in reality, it was a bit of everything that we were doing. We moved through to some passive house ideas with SIPs back in 2011, and Brett, who's beside me here, automatically seen there was huge value in being able to offer a healthier, energy efficient home. And as we still moved through that pathway, by 2017, we took the opportunity just to specialise in that. And we still see potential growth in high performance homes, and as a result I've come and joined this business as well, and we did a wee small name change from Chatterton Builders to Chatterton Homes to reflect our focus around delivering on things. So hey, we've got a new one as well. Welcome. We're just doing a bit of an intro. So as I said earlier, from 1998 we mainly were doing hillside homes, but since 2011, high performance has been on the radar, and that has been a mixture of certified passive homes, so for owner builds and also consulting for others, and we've completed over 80 SIPs builds throughout New Zealand, and we are one of the most experienced SIPs builders in New Zealand. We also offer some other services, such as air tightness tester. We have a certified and qualified air tightness tester to see how airtight buildings are, and also have people on board that have completed the passive house tradesperson qualification, which is a very in-depth and detailed process around what it actually takes to build a passive home. As with anything, it's always good to reference what's happening in the building environment and providing some background. And obviously, building code is quite topical at the moment with change of government from just over a year ago, and what that's sort of impacting on the pathway that was laid out into what's happening now. We have, obviously, from a New Zealand perspective, there's always pressure around sustainability and energy concerns. We move on to health issues, whether it's occupant health and well-being, what can we do to make homes healthier? And then we put that in context with the current building code and upcoming changes to the building code, which are required for us to meet international carbon emissions and climate change deadlines that we've signed up to. So it might be a bit small on your screens, but we can share some more detail around this information. Some of this is changing with National's focus around here, but when we originally were pulling these up under the strategy document, which is still current, they were talking about by 2030 having thermal performance, which is the energy demand for your home, to be lower than 15 kilowatt hours per square metre, which is actually a passive standard. So that was a target that was to be come into code. We generally don't think that will happen now, or it's going to be on a different pathway. National's focus is not so much heading down this pathway anymore. They just want to get quality homes, but they're more open or less prescriptive around what the targets are going to be. So that's sort of where the strategies where the government's at, and as I said, where they're currently consulting on the building code. We've put a submission in along with NZ certified builders where we think improvements could be made and areas that they should focus, but we'll now have to wait to see the outcomes of that and to get the actual direction that National's going to take. But assuming that the general pathway, if we look at international trends and what's commonplace overseas, why should we consider changes that are going to improve the health of our homes and the performance of our homes from an energy use point of view? And what we've seen so far is the pathway, that the changes that have happened to the building code, people may have heard of H1 and etc. They have narrowed that price gap between achieving a passive home versus a standard build by bringing up the standard of all homes. And further changes in that direction will continue to minimise that gap. And I suppose it brings the cost of the minimum code build and a high performance home closer together. So importantly, those changes actually benefit who lives in the home. So it's not about just what it costs to build the home, but what it costs to run and what it's doing for your health while you live in it. And so by increasing those standards, you have less risk to your building, the integrity of your building, and you also have some very good energy savings. It also contributes to the sustainability for the homeowners by saying that overall, for any new home that's built, we're doing our bit for the planet by making sure it's efficient to run and not a leaky home from a heat and energy point of view. There's some of the specific changes that have come in that are there now is around ceiling insulation, and for ceilings going up, or for roof insulations, R6.6, and obviously some changes to framing thickness, now exterior framing to be at that 140 millimeter. Twofold reason for that. Most people are thinking it's just for insulation, but it's actually also for bracing elements. It increases the ability to have those bracing calculations improved. So it's a twofold increase for the twofold benefit for that increase. Our standard builds that we do with SIPs are 165 millimeters, so very close to a 140. But that's the thickness of the panel we generally start with. So the question is, how do we achieve affordable high performance? Now, obviously, we believe the only way to achieve a truly comfortable, healthy, and energy efficient home is by the application of passive house design and passive house principles, and getting that into the design and the build. Adapting these principles does not mean that you need to go to certification level, but actually applying those principles consistently is what's going to get good results. So it still remains a robust and comprehensive design and build process where all factors are considered, from site location, orientation, window sizes, all those things. The cause and effect of the building design is covered off, and we don't look to do isolated fixes that then might have negative consequences. A key part to that is making sure we do the thermal modelling. Energy savings and performance that we can generate in the model then gives you the baseline for how the home will perform when it's finished and you're living in it. You can always opt for more testing and go into verification or certification if you want, but the key is through that design phase, doing the modelling and getting the answers that you need on paper before you commit to doing the build, so you know how the home will perform. And we're one of the few in Canterbury who incorporate passive house principles into all of our high performance homes, certified or not certified. That's still our focus, making sure we're going through that step-by-step process of the passive house principles. So what are the principles? There are 5 key passive house principles, and we've got them all in that one diagram there. The ones we're probably readily aware of are insulation, obviously, that's one key one. Air tightness is the other big key one, and then mechanical heat recovery ventilation, MHRV, that is the third. There are 5 in total, but those 3 are sort of the tripod on which everything stands. If you don't do one of those 3, the tripod will fall over. And the other two aspects to passive house design are thermal bridge management, which we'll talk about shortly, and then making sure you actually have high performance windows. So, and we'll talk about the reasons of that as well. But as I said, the principles work in unison. The idea is they're complementary to each other, that through the design phase, you're looking at all those aspects. If you miss that through the design phase or missing one of those steps, then you will have some unintended consequences, i.e., if you don't have an airtight home, you will have increased heating need because you'll be losing heat to the outside environment. If you have air tightness without ventilation, you have potential of then having humidity in areas and causing potential molds. And then if you have ventilation with no insulation, then you're still going to need more heating because so they need to all be working together. So I'll just quickly run through those 5 principles. So there's 2 on a page for here, and just talk about why they're important and what that practically means. So with insulation, the whole point of insulation obviously is to prevent heat energy escaping the building envelope. Warm air will always try to move to cold air, or cold air will always try to come into a building, and the insulation is there to help prevent that movement. Ideally, insulation is best when it's a continuous layer to the floor, walls and ceilings, and therefore no interruptions through that insulation layer. When there are breaks or compromises in the layer, such as putting a door in or a window, because we can't live in a windowless box, then we need to make sure that we're considering the impacts of those elements. The insulation requirements were increased in 2023, which is very good. But then the other comment we'll put in here is the other key part of insulation. There are sort of two levels: insulation as it's installed, and then insulation as it performs over time. So if there are gaps when it's been installed, or if it's under compression and not in its right, not installed the correct way, or if it sags over time, then they all start to impact insulation performance of your building. So that's insulation. Air tightness is about controlling air movement, or more correctly, controlling or not having uncontrolled air movements. So making sure we don't have drafts, making sure that from an air tightness point of view, allergens just can't come into the building through walls or through gaps. And it's also about limiting cold air entering or warm air escaping. So we want to make sure the building envelope is airtight. Most new builds built to minimum code will be in the range of 5 to 10 air changes per hour. That's generally what most homes would be achieving if we were to put our air testing machine on. And when we build, we're aiming for 0.6 air changes per hour. So substantial difference between a new home being built versus a new home built to passive standards or passive house principles. 0.6 is the International Passive House minimum requirement for air tightness. One of the key things for air tightness, which works in conjunction with all the other principles, is it provides a controlled space for your mechanical ventilation unit to work effectively and efficiently. If you've got gaps all over the place where air is escaping, your ventilation unit will not be working as efficiently as it could be. By having good air tightness and a good heat recovery ventilation system, you can be achieving 90 to 95% of efficiency in heat recovery. So what that is bringing fresh air from the outside, transferring the heat in your house with the air we exhaust, and recovering that heat. And we can get very, very good recoveries by having a combination of a good MHRV and air tightness. Having an airtight building also aids in soundproofing. We didn't also mention insulation, but our SIPS panels from an insulation point of view also do that. And then there were to be air tightness requirements to be introduced this year, but all those have been put on hold as they go through consultation at the moment. But we see that as a good step, because as I said at the start, those 3 key principles of insulation, air tightness, and ventilation, they need to be done in unison, not separately. So moving on to ventilation. And MHRV system is about controlled air movement. It's about making sure the incoming air enters that unit where it gets filtered before it is heated through a heat exchange plate by the stale air that we're removing from the home. We're reusing the heat and not wasting it. And that works best when there's no uncontrolled leaks. It also means there is a constant supply of warmed, fresh filtered air into every room in the home. And the humidity as a result gets managed by limiting moisture entering the home through that unit, and also by making sure we're extracting from areas that could be creating moisture or humidity. The other key part of these ventilated systems is allergens and outside particles can be filtered. We can remove up to 95% of allergens, which makes a very big impact from a health point of view for anyone that has allergies or asthma. We get lots of anecdotal evidence about how improved lifestyles become in these homes. We have extract vents in the bathrooms, the kitchens, the laundry areas that remove moisture as it's released from cooking and washing. The heat is also extracted and passed on to the dry air coming in. This maintains a constant, comfortable temperature of extract heat that warms the incoming air. And that heat deficit can often be made up without needing to put a heater on, but just by having appliances or people living in the home is more likely enough to maintain the temperature in a building. Where more heat is required in those coldest or warmest months, there might need to be a small heat pump, which can do the peaks and troughs, fill in the gaps if things are not quite as comfortable. Now, the final two pieces of the principles are thermal bridge management and high performance windows. So a thermal bridge, I suppose, is likened to a highway where heat or the temperature inside can move out. So normally we talk about steel. If it penetrates through a thermal envelope, it can take the heat from inside the building very quickly to the outside of the building, because we know metals can conduct warmth really well. The other part where we start talking about this is when we have timber studs that are in place in our SIPS panels, where there is timber all the way through from the inside to the outside. We normally would then make sure we provide a thermal break to not have any direct contact from the inside of the house to the outside of the house where heat can escape. The most common one in New Zealand has been the good old aluminium windows from non-thermally broken aluminium windows. That's probably where most people are aware of what a thermal bridge is, where you see condensation building up because that temperature change is so apparent inside the home. That's moving on to high performance windows. So that's what we consider not just a standard window, but we look at the framing of the window and the glazing of the window. They both need to be considered. So whilst UPVC or timber are preferable in terms of their thermal performance, we are still seeing increasingly better aluminium options come on the market. Now, as the building code has moved to thermally broken aluminium as the standard, that used to be the optional extra for aluminium windows. And so cost is a factor when looking at windows, but it can easily be modelled and we can weigh up its performance versus the cost. So with that modelling, you get an idea of the cost to upgrade your windows to something that performs better, but you also see the impact on your home's performance. Regardless of which window is chosen, the most important thing is that we recess the windows into the insulation line. That is a key requirement for all windows that we use for all of our builds. So we can still have aluminium thermally broken windows, double glazed, that perform very well because they're recessed and we take care around how they're installed. So that's a bit more detail around the 5 principles. So how do we tackle a design and build process to ensure families have access to healthier, more comfortable homes that cost a lot less to run? And we do that by having 2 pathways. So our first one, we design and build to your budget. So that's a custom design project to your land, to your specification, and we work to a budget. And then the other option is going off our high performance SIPS plan range. And this is an alternate option of how we go down this pathway, but we'll step through both of them. But the plan range is a bit more fixed, but because it's fixed, we have upfront certainty around the cost for those footprints. So I'm going to talk now about the design and build pathway, which is how majority of our 80 builds have been done. Our off the plan range is new, and I will get into that shortly. So for a design and build, it's all about your involvement, your decisions. You have the choice and flexibility on the design, the materials, and you have the ability to create a unique design to suit you, your family, and your tastes. And it's your ability to design to your particular section or the environmental conditions of your section or your location. So the key part to that is getting the right designer, and then obviously having a builder involved like us that can then help to get accurate estimations through that process before you commit to working drawings. Tips for achieving a bespoke home to a budget. First and foremost, know your budget. What does this need to include? Does it include all the externals like the driveway? Does your section need a septic tank? Have all these things clear in your mind around what your budget needs to be. And then know your priorities. What do you want to achieve, or what do you want to have now? The key is you need to be very clear about what it is you're wanting out of the project, and what level of performance are you looking to achieve. We always say from our building perspective and from the passive house principles point of view, invest in the envelope first. If you get the envelope right, then the rest of the build and your option choices are a lot easier to make. The other key thing from our perspective if you're looking at a budget is having a simple form. So that's the design and the characteristics of the home, not only for better performance overall, but it also makes it more affordable if the structure is standard with not lots of internal corners, and if it's more of a simple structure and design, that'll make a big difference. The other one we work through with most designers is having a smaller footprint. One of the benefits of a passive principled home is you can have multi-use rooms, because every room in the home becomes the same temperature, the same environment. You don't have rooms that are shut off and never used except for one or two things. You can now create multi-use areas. Having a good designer that can integrate clever storage and reduce wasted space. If you get this footprint smaller and you'll still have all your living requirements, then that obviously is going to bring that budget, make it more budget friendly. Then talk with the designer about incorporating any future expansion. If you have an idea to expand it down the line, how would this work, and make sure it's factored into the original project. The other key part which we strongly advocate for is get the builder involved in that design stage. We are a key source of experience and knowledge. And also it just means that if you're very clear with your budget, we can tell pretty quickly if it's moving out of that realm with some of those design decisions. So we can provide then a complete estimate of concepts and confidence before you proceed to alter or anything else that you want to do. And the other part we recommend through this design phase is thermal modelling. So then you can make choices on what level of componentry you have in the home, and you can see the cost of that and weigh up the benefits that it gives you from performance. So that's our tips for achieving that bespoke home to a budget. Here's some photos just of some of the design and builds that we have done. So you can see some of them have got that simple form, and makes it easier from our construction point of view to maintain an envelope and build to their required budget. Again, if there's any questions about those, just let us know. We can talk about more specifically on those, but that's just a sample of some of the design and builds we've done. And some more. You can see we also use some shading and bits and pieces that are in there, which is all coming through from the thermal modelling where we need to have shade. Then we move through to our plan range. So this is a different option. This is now working from a set number of plans. that we have already developed using SIPs and passive principles, and then having a known upfront fixed cost investment for your build. The plan range also greatly reduces the design process from a time and money point of view. Just for your interest, most of our design and build projects, a very fast project might come out of design phase after about 12 months. We have a number that sit in the 18 months to 2 years, and we've had others that go longer. So design phase can be very long. Design and build can create quite a long lead time if you're building and designing from scratch. The plan range is already, most of that design work is done. It's just about your section and any other tweaks that need to be made. So we can make some minor internal modifications to any of our plans. The envelopes are fixed. So anything around the exterior is fixed, and all the windows are fixed on those exterior sides, but we can make minor internal mods. Each of our designs incorporate all 5 high-performance principles, and we've done thermal modelling for all the designs, which we can then allocate to your site and location to show you how those homes will perform for your section. So we've got a range of plans from 3-bedroom plans. Here we've got a couple. The top one is our Fernside, which is also our show home, which is in Amberley, and then our Waikuku, and then we've got some 2-bed and 4-bed options, which we can walk through. So just showing we've got a range of options that people can look at as a ready-to-go plan that they can start working with. This sheet here just covers off the key differences between the 2 processes. So we've got in column 1 is the custom design and build, and column 2 is a high performance plan range, and then down the side we talk about 5 key aspects. So if we talk about performance, for a custom design, all 5 principles of Passive House are incorporated, and the degree of incorporation is influenced by the goals of you or of the client and their priorities and constraints. We do use thermal modelling to gauge performance expectations. And for a high performance plan range, all plans incorporate Passive House and have undergone thermal modelling, so expected performance is calculated, and further performance upgrades are available if you want to upgrade componentry. Orientation. So site first, a house can only be designed to the section. So that's the key part for a design and build. We can't start a design and build process if you don't have land. So it's a site first or a section first process. Whereas our high performance plan range, you can start with the plan. The site will dictate if the plan can fit, but we've also helped a number of people find sections that fit the plan that they like. So that's gives a bit more flexibility if you don't have land already. In regards to cost, the build price is not known up front, but the goal is to design the home to your budget. And there'll be opportunities to change scope or develop ideas which can influence that final investment price up or down. It's a full design process that's required. So the cost really comes down to more than just a plan at the start, but it's who's doing what you've allowed for, and how the scope changes as you go through that design phase. Whereas the cost for the high performance plan is set. We know the build price for the plans, and the inclusions are nice and clear up front about what's covered in those costs. There may well be foundation or specific site needs that need to be considered if you're in TC3 or some other, or on slopes or any other areas where those foundations will need some more work and detail. And this is an unknown portion and can then add to the build cost. We have a certain allowance for what our base foundation would be, but if there is engineering requirements to go beyond that, then we need to have some discussion around that. Generally, the only design costs involve the site set out. We've done all the other work, so it's physically just locating the plan on your section and the site's foundation requirements. That's the only design costs that are really needed through that high performance plan range. The key one is time, and that's when we get to a build start. As I mentioned earlier, the longer design stage through a custom design and build is can be on average 12 to 24 months, including consent. There's additional processes required. We do an estimate once you've finalised on a concept plan. Once you've gone through all the initial bit and got your original plan, then we do a QS pricing estimation. And then if that looks to be in line with your expectation, we can then go through to work to sort of completed drawings ready for consent and get that fully priced for us to then fix a build price for your build. But that'll only be at the end of that design process before you know that. Whereas with a high performance home, there is reduced design time because that work's already been done. And we would suggest from initial contact, 3 to 4 months, including consent, is when we can start building. So if you compare that to the other side, we're talking 12 to 24 months, including consent. That's a lot faster to get moving on your project. The key for this is simple structures, and familiarisation with the design means that we can also efficiently build these plans. The last factor to consider is the ability to alter them. In a custom design, every aspect can be customised within the budget. Whereas with our plan range, we can't do structural changes. There are only minor changes only, such as internal modifications and also some colour choices. So that's the limit. That's the difference between the two options. So that explains our 2 steps that we offer for our design process. So then it comes down to what's the best option for you. It's about understanding your needs and priorities, your constraints and your concerns. And we definitely welcome, if you want any advice from us, to have an initial consultation where we can talk through those. We'll have a meeting. We'll listen and we'll understand to what you're wanting to do and make sure that any advice we're giving is going to be a good fit for what you're wanting. So it's about starting your journey. If this is the first time you've come across us and having a chat with us, then chat to us now, and we can arrange a meeting. You might also be aware, if you've registered for this event, we do have a mid-build, which is an opportunity to come through a house that's under construction before we do the internal lining. So you can see the SIPS panels and the ventilation before it all gets hidden behind the jib. And that's on next week in Hallswell. And if there's any other questions, just either talk to us or type something up in the chat.